Test. Are you? Hello, guys. Looks like I'm late. S- So, actually, I'm not sure what to talk about. Let's see if people are coming. Well, I'm going to talk about. Let's see, what is this? Okay, so go to my Emacs blog. Go to my programming blog. Go to my Emacs blog. So I'll be talking about. Okay, I can talk about. You see, I'm starting streaming, so I don't know what to talk about. Well, I have some ideas. So there are several type of things I can talk about. I mean, for one thing, I can focus on a technology. For example, Emacs. I'm just go on and answer Emacs questions. Talk about Emacs, like what is the most efficient way to open files and things like that. Now, the other way is to, I mean, okay, so there's technical topics, Emacs, very focused, specific topic, or about a programming language, for example, JavaScript or Golang. Actually, I'm not really in the position of teaching Golang. Um, well, or or JavaScript. Well, because in order to do that, you have to be proficient. Not, I mean, even if you understand the language very well, but if you haven't used it, for example, in for a while, then I mean, then you cannot, because you have to be quick, on the spot, know the syntax, and do stuff. But anyway, so I can talk about Emacs, well, Emacs and Emacs Lisp. I still do daily. I still code Emacs Lisp basically daily. And so, very focused technical topic. That's one way to go about videos. The other way is to, let's see, the other way is to talk about technical topic like programming, but not necessarily very focused. For example, I can talk about programming community, Emacs community, for example, Richard Stallman. Now he's always an interesting character. There's always lots of things to talk about, and Emacs code, for example. Oh, Emacs code, that's a huge topic. Let's see. Oh, one guy watching. Good. So Emacs code is a huge topic. For example, Emacs. Let's see. Emacs modernization, Emacs fun. So there's a Emacs cup. Oh, this cup. It uses this line, in a cloud, bones of steel. That's great line, and that line is actually from a poem, and it's quoted. It's used as GNU's motto. But anyway, so back to the topic. So I was saying, when I do a video, for example, a Xah Talk Show, I can do focused technical topic or general technical topic like programming community, Emacs uh, uh, culture, Emacs community, Emacs people, what's going on in Emacs community, um, or then the third option is outside of technology, and over there's also lots of things to talk about. So actually, let me know if you are there. I got four guys watching, so yay. Four- so if you are there, just type things out. Let me know what you want me to talk about. So actually, let me try. Say hi and tell me, and vote for what topic you like me to talk about. So I can talk about Emacs Lisp demo, for example, or there it is. My message is great. Or uh, general programming stuff or programming language, syntax and design, and formal languages. Now that's my favorite topic, formal languages. Um, okay, so those are technical, all these are programming related topics. And then outside of that, there is general social topic. For example, I'm interested in linguistics. For example, I can speak or write Chinese. 大家好，我说中文。你们会说中文吗？我可以教中文。For example, I can teach you Chinese. The basics, or tell you some general ideas about Chinese, the grammar and how things are. Or, so these are non-technical topics. So I can talk about Chinese. I can talk about China. For example, China is getting huge today. They landed on they went to the back of moon last month. And China news like today, all the the longest bridge, the biggest buildings, the tallest, the highest elevator, and the biggest Ferris wheel or something. It's like all the biggest is like all China now. Iceland Jack, hi. I know you. You are the guy with all. Actually, I'm not sure if you are a guy or a girl, but I noticed you. You are the guy with the blue hair. So syntax formal language, yeah, that's for my. But I know you. Okay, Emac Lisp, yeah. So Haskell. Okay, I actually don't know much about Haskell. Although I rant about it all day. Because okay, so Haskell functional programming, but I love functional programming. So I was going to say, yeah, what it was. Oh, formal languages. So if I'm gonna talk about formal languages to a Haskell guy, you know, you probably gonna be disappointed because you probably know much more technical details. Uh, you know, because if I'm going to, if I learn Haskell, if if Haskell is Emac Lisp, which I've been coding for 10 years, then I can ramble on and on like about the details. But I actually don't know Haskell. So my comment about Haskell is just it's actually just general flaming, because well, anyway, so let me show you. So I can okay. Just let me finish the topic. And so I tend to ramble a lot. Like this one path. Then I go to this direction. Then there's a branch and then branch, and I like reach. So in the programming, there's an algorithm, a general category of algorithm called backtracing. So so it's like so you have many branches, and once you reach the end, you backtrace. So I go back to the previous topic, then talk about that. It's like parentheses in Lisp. You have so many parentheses. You start a new parenthesis, then you finish that. You went back to the outer parenthesis. And there's an interesting thing about that is the story within a story. The actually yeah. So I'm starting to ramble a lot. So anyway, but that's a fun part, because usually like it's great if I talk about one specific topic like Emacs, people are interested. But then sometimes, that kinds of get boring because, and I mean, if you really want to know Emacs, specific question, there's tons of answers, and often you can just read, like Stack Overflow, you just go there and read it. So I mean I'm guessing the purpose the let's see if I can see myself. Where's my hand? Okay, there's like a 5-second delay So anyway, so so yeah, so I mean I guess the fun part about streaming or video is that you see people talk, and you talk just about things like in real life. You talk to your friends, interesting people, um, and various things. But anyway, so I have wrote, I have random interest, lots of interest, but usually they are academic things, like philosophy, linguistics, usually academic literature and stuff. But in literature, there's Arabian Nights. Oh my God, this I would say Arabian Nights, the the Arabian Nights, the version by Sir Richard Burton. Oh, he's a very interesting guy. Now the version, he's the one who translated the whole thing in English without censorship. As is. And so I mean, this book, that's a huge topic. That's a very rich topic. So anyway, he's the first one to translate it, and he's lots of things. He's a linguist. He speaks several languages. I mean, this is like in 1800s. He speaks several languages. He's also a fencer, a swordsman. He's also a diplomat. He has been, and he's also lots of things. So and anyway, so Arabian, Arabian Nights or 1001 Nights. That's the story where, if you are a typical American, um, the way, I mean, the way you understand Arabian Nights, like from Disney, that's all like that's out of shape. That's not Arabian Night at all. So you want to read this one, and the way and I find this book, actually I would say I find the most interesting book, my favorite book. Yeah, I can say it's kind of like my favorite book, fiction or non-fiction, kind of the top, let's say top five of all the books I've ever read. So Arabian Night, that's so it's interesting. The king, uh, and also the stories that we are familiar with, the Alibaba and 40 Thieves, the Aladdin, uh, and the Wonders of the Seven Sea or something like that. And actually, the those are not the core of Arabian Nights. But anyway, so well, I'm talking about Arabian Nights because Arabian Nights, the story is structured in such with recursion. So, for example, they start a story, and this girl, Shahara Rad, something like that. How do you pronounce her name? She started to tell the king a story. Then within that story there are people and characters, and those characters started to recount another story, and so on. So it's like nested, it's heavily nested structure. So that's so anyway, so that's I'm mentioning that uh, formal languages. Yeah, I don't know about, let's see my blog. So formal language, I well, so I'm not sure I can talk about that. And this, I'm like, oh my God, formal languages. Okay, so I don't know. If I'm not, I don't really know that much. Okay, let's just let me just ramble then. That because I do the best. I mean, that's the best thing. That's the best thing I do. So so I have a lot criticisms about programming languages. Mostly, okay. So there's this Lisp. All these articles are related to Lisp. Uh, I have, so well, I was going to say, these people, especially this today is kind of dead. Okay, yeah, I mean, it's not like before. Suppose in 1990s or 2000s, there's a huge subculture or group of Lispers. They want Lisp. Like, okay, in today maybe that's something like Haskell. You know, uh, a lot of people say, "Oh, this is the only way." So back then, there's a lot of Lisp and Lispers. I have a lot fight with them. In general, I like Lisp, but mostly I like the functional programming aspects, not not any particular characteristics of Lisp. Lispers, for example, if you talk to Lispers will start to begin to tell you, oh, the parenthesis is great. There's this called what they call it. Um, there's a word for like semi-mathematical phrase. That so what does that mean is that it says the data structure and the Lisp syntax is isomorphic. It means something like that. Okay. Yeah, that's it. Homoiconicity. you know that's the most idiotic concept. uh so that I have a lot of rants about Lisp, because in programming community, especially the hacker types, which is most of my readers anyway, because I just wallow in Unix and stuff, and they now and then you hear people, the hacker type of programmers, they mention like mathematical jargons, but in fact, if you are a mathematician, and you read that homoiconicity, like nobody uses, and that is actually not a mathematical jargon. I mean, you don't find that in math. And as far as programming goes, what does it mean? It's like it has no utility. I mean, usually math terminologies, each term, group, we can, I can, start to go on to Wikipedia, list the, math terms, isomorphism, isometry, projective space, homomorphism, or lots of there's huge amount of math jargons. They have very specific meaning. Sometimes different author have different definitions, but in general they are the same. I mean, you can change a little bit, like trivial things. Do you include zero or not? Special cases, but in general they have very specific meaning. But also they are practical jargons that you need to use it often, because otherwise you just have to say the whole definition. It's problematic. But but then you look at the some people, like some of the math like terms propelled by programmers, it's never used, and it's silly. It's almost like there's no definition for it. There's no exact definition, and even if you give it a definition, it's not useful. I mean, it's not. So what words are useful in programming? For example, variable, function, side effect. Side effect of a function. For example, mutability. That's useful, although I don't like that jargon. But it could useful. There's a thing about mutability. Interesting about mutability, because if you have a list, in most languages, almost basically all languages, if you have a list, and if you assign it to a variable, the question is now, is that variable mutable or not? That's an interesting question. Let's say this is not Haskell. Let's say this is in Python or Perl or PHP. You see, in one sense, the variable is, if you say the variable is immutable, that means you cannot assign any other value to x. once you assign it to a list. But you could also say it's mutable because the list element itself is mutable. However, the list, the value of the variable is actually a reference to the list. So you have like two concepts. you know what do you mean by mutability? Do you mean the list itself is mutability, or the value of the variable? So that's interesting about mutability. So back to the so I was saying, okay, about jargons, homoiconicity. And actually, if you look up Wikipedia, homeo actually, I probably have an article here somewhere. Anyway, let's look up Wikipedia. Something like that. It will tell you actually a lot of other languages have that property. I mean, when you actually hear the other languages with that property, then you suddenly realize it's stupid. You no longer want to say, oh, Lisp has homoiconicity, anymore. Like all these languages, actually, they used to also include assembly. Uh, you know, uh, so it's like it's extremely stupid. But however, my take about the situation, where in Lisp you have parentheses, right? Let's see. Okay, so let's go here. So in Lisp code you have all these parentheses. Okay, you want to talk about homoiconicity? I mean I don't mean you, but I mean the the Lispers. And they so but notice one thing: the Lisp syntax is not regular. Notice this one here. Okay, so let me see. Let me find an example. Okay, let's go. Fundamental problems of Lisp. Lisp people like to say, oh, we like, it's regular. Lisp has no syntax. That's a stupid expression, because every language has a syntax. So it's kind of like idiomatic English. When you say something is no syntax, it actually means, it's kind of like regular. So you don't have exceptions, or lots lots of things to worry about. But anyway, so these people, like to say they have no syntax. So it just means it's very regular, but actually it's not. You have special things like that. Then you have, the quote, special syntax. Then you have, the back quote, and then you have that. So they have a bunch of things. So you know, I actually really like it to be regular. So in a sense, I really like the icon, homoiconicity idea. So I want it to be extremely regular. I mean, I just want nested parentheses. So in other words, the Lisp grammar can be specified in just like 3 lines. That way it's pure, 100% regular. But actually, in almost all the lists out there, they are not regular except Mathematica. Okay, is except Mathematica, the Wolfram language. But the general Lisp, Emac Lisp, Common Lisp scheme, they are not regular. They have these kind of things. So you talk to these people, you say, well, you show them this issue, then they are like, oh no, but we need that because it's convenient. They like totally fucking idiotic. The reason the reason the Lispers behave that way. Concoctive. Okay. Yeah, I'm concoct concatenative languages have true homoiconicity. Well, I'm well, I guess that depends on what we mean by. But anyway, first of all, we have to actually define what iconicity means. But anyway, let me finish here. So you see what I'm saying is that I want a Lisp language where the syntax is 100% regular, but actually Lisp's the common Lisp, scheme Lisp, racket, they are not. They don't have a regular syntax. Um, but actually Mathematica language has that property. Now this is interesting. Most of you probably are not familiar with Mathematica, but Mathematica is a language that actually has that property. I mean, it's just like purely nested expression. Actually, let me show you an example here. So let's magnify. So if you look back here, okay, let me just go page. Okay, so for example, this is Mathematica or Wolfram language. It has what's called M expression. In Lisp you have S expression, which is the familiar nested parenthesis. But actually, the original Lisp inventor, he has the concept of M expression, which is a wrapper, a syntax wrapper to the S expression. So you have X expression. Let me go to okay here. Open that and open that. So let's see. Go down. Okay. So yeah. So these are S expression, symbolic expression, but M expression is supposed to be like, for example, like that. So it's a syntactic wrapper to the S expression. That meaning that it can transform to the S expression. So that's the original idea concept of Lisp, by the guy McCarthy. But however, it just never came to be. But Mathematica, the Wolfram, Stefan Wolfram guy, he created Mathematica. He actually did the M expression, meta expression. So let me show you quickly what I mean. So here is Wolfram code of Wolfram language Mathematica, and there's two versions. Now, first of all, look at this. Look at this version. Let me turn off the auto click. So look at this version. You notice the syntax is nesting, pure nesting. So the form is F, then a square bracket, and then that's it. That's basically the grammar. So inside it, you can have more of that form, more of the same form. And so this is isomorphic to a pure Lisp S expression. So the function name is outside the bracket instead of inside the parenthesis, and also the separator is a comma instead of space, and that is it. And it is 100% pure. There's no exceptions. So this is shown in this version here. Now every expression can be also converted to the M expression. In Lisp jargon it's called M expression, but in Mathematica it's not called M expression. So in Mathematica, this version of syntax is called full form, like full form. That's a word here. And this version is transformed to this version. In Lisp you call it M expression, but in Mathematica it's just it's called standard form. These two are these two can be converted to each other just by pressing a key, and they are pure syntactical transformations, meaning that this form or this form, they are exactly the same. For example, when when you write 1 plus 2 in any let's say in Python or whatever, 1 plus 2, you can add a space between you know before or after the plus sign, and both ways are 100%, they are syntactically equivalent. That's what I mean. So these two forms, although they look different, they are syntactically equivalent, and you can just press a button in an editor to transform one to the other or part of it to the other. So I have a detailed explanation, a lot of detailed explanation about Mathematica syntax, and how this transform works. But you can read it if you want. So anyway, back to so I was ranting about this, but anyway, so back to so I have basically these three sections. Okay, the four sections. So this section is on Lisp, and this section, syntax soup, is about many issues about syntax of different languages. And here is a collection of articles related to semantic issues. So on Lisp syntax soup, semantic noodles, what a great name! And overall, they are comp-lam perving. And okay, the other thing about Lisp is, Lispers are crazy about markers. This image I found somewhere in Chinese programming forum. Someone created it. It's so funny. So Lispers, they are so excited about Lisp markers. I think it's the most idiotic shit in programming languages. The most idiotic shit, useless fuck. You know. Also, let me talk about Mathematica. Mathematica, you have pattern matching. The pattern matching in Mathematica is different from those in Haskell or Camel. Okay. Now, I don't actually know Haskell much. I never programmed Haskell actually, except maybe 10 lines. Just learning it. So I could be wrong, but the general idea, but I know for sure that the Haskell pattern matching, or in OCaml or other languages, they are pattern matching by value. Okay, let me back up. So no, you guys probably know in Lisp you have symbolic expression, right? So meaning that Lisp is different from other languages. For one of the primary reasons is that it has symbols. Like every character is a symbol. The Lisp compiler, or read your file, and they turn those your source code into a bunch of lists. But anyway, so Lisp has the concept of symbols. Like when you say x equals to 3, x can remain x, as a symbol, kind of like a string, kind of like an inert string, and you can choose to evaluate the x or not. But in Python, for example, if you say x equals to 3, then x is always just 3, and there's no way to get the x as a symbol back. So that's one of the major difference between Lisp and other languages. So Lisp has symbols, the concept of symbols. And so once you have a symbolic language like Lisp, and Mathematica as well. So in Mathematica you have pattern matching, meaning that you are doing transformation of expressions symbolically. Okay, that's a key thing, symbolically. So if you know Lisp, basically that means macros, Lisp macros. So Lisp macro, what it is doing actually is just manipulating the expression, the symbolic expression. More specifically, you can hold a value, don't let it evaluate, hold it, and then you manipulate it, you transform it into another nested expression, then you say go evaluate that. So that is actually a form of pattern matching. You match patterns symbolically, okay? That's the important thing, symbolically. You take the expression, from your source code. That's a list, a bunch of symbols. You manipulate it. Then you tell the the program, the interpreter or compiler, you say go evaluate that. So this macro is that, but it's not actual, you don't call it pattern matching because it's very limited. All you actually do is, when you define a macro, you just hold the input, the parameters, and it's very, yeah, I mean, in this way you can see it's very limited. You actually don't transform the expression much. Okay, but in Mathematica, which is a full symbolic pattern matching language, that's what you do. You take any expression, anything in your source code. That's the primary way Mathematica computes, by symbolic transformation of expressions. So this macro is like one limited pattern matching, but Mathematica, it's the whole thing is pattern matching. I mean, it has other things as well, but one of the primary way for Mathematica to do computation is by pattern matching. You take an expression, you transform it to whatever you want, and you evaluate it that. So that's Mathematica pattern matching. Now, as I looked into Haskell. I'm curious. Haskell, other pattern matching, they also have pattern matching, but they are not. The difference is that they are not symbolic. They don't have the concept of symbols. So they are pattern matching by expression structure. For example, list structure, something like that. So that's it. So that's a difference. That's major. That's very big difference because when you do symbolic pattern matching transformation expressions, you are doing transformation of expressions. But if you are just pattern matching on values, that's still helpful, but that's a major paradigm. That's a different. It's not symbolic pattern matching. It's not transformation of the expressions anymore. But of course, it's still useful. So anyway, so I was talking about, yeah. So okay, list macros. Okay, so okay, let's go back to what I'm gonna say about formal languages. So I find myself, my interest in languages. Like every person, you have, maybe you are a fan of Python, and you like Haskell very much. You like this, some people like Java, there exist. Does there Are there people like Java? Yeah, I know. I think they are. But then so my I find that my interest, when I criticize, languages, which I like, which I don't like, I find myself the reason. I mean, if I can summarize, the characteristics of languages that I like, then I think I can say it's because they are, the closer the language is a formal language, I like it more. I like it to be formal language. Um, Now, aside from that, I also I want the language to be no exceptions. Like everything is 100% regular, 100% regular syntax. Like Lisp. 100% regular semantics. Like there's no, like each syntax doesn't matter where it is used. It means exactly the same thing. So in a sense, I like them, so the language, so I kind of like those characteristics, those properties. No exceptions, pure regular syntax. But anyway, so back to formal language. Now, for those of you who don't know, you can look up Wikipedia, what did formal language. So here's what I say, syntax is the most important aspect of programming language. the quality of a programming language can be judged by how much of it can be explained by its syntax alone. You know, if you take these criteria, to judge languages, and if you look at Lisp, that applies very much, because when you look at Lisp, first of all, you see all the parentheses, and quickly you understand that each parenthesis, the beginning is a function name, and you can just read that. The function name pretty much describe, what the function does, and it's all nested. So in a sense, Lisp, even for someone who never, looked at computer languages before, it kind of, tells you already what it means, what it do. So that's what that that's advantage. That's why I like, Lisp. Um, but for example, Python, Java, especially Java, so fucked up, and JavaScript, you cannot do that. You look at the program, you have no idea what's going on. Like I mean, especially so that's what I like. Haskell is a. I also like functional. It's a must. I only program in functional programming style. Um, I don't like OOP at all. I think OOP is a scam. And also if you have comments, just you know, comment. Let me know. So let me know where I'm going. So I can talk about it. So the other language, so I was talking about, yeah, so I don't like OOP at all. So I like functional programming. And also functional programming, the term has kind of evolved, in the past like 20 years. Before, Lisp is functional programming, but today people say what? you know because Lisp has lots of side effects, because today Haskell is, kind of popular, right? So Haskell, gave the world the sense that functional programming is, without, you just write functions and without side effect. But actually, except Haskell, almost all other functional languages has side effect, including OCaml, F sharp, ML. Those are all the same family. Um, Lisp, Mathematica, there's a lot of functional programming languages, but they are not like Haskell. Haskell is almost basically the only one that actually does, in the language enforce, the idea that there cannot be mutable variables. So closure is also functional language, and Racket, yeah. Racket Racket or Common is for non-Emacs desktop programming. What do you mean? Do you mean are they good or bad? I think they are. Okay, I don't like Common Lisp, but anyway, but that's just my opinion. So you can, I mean, Racket and Common Lisp, you can use them. I mean, the thing is, when you consider, I never had experience with Smalltalk or Faro. What language is that? So I mean, the thing is, when you consider which programming language to learn, there's a lot. It depends on what you want to do. If you want to get a job, Racket, no. Common Lisp, no. If you really, I mean, if you want to get a job and you insist on using Lisp family of languages, then go for Clojure. That's your best chance. But even, I mean, let's say there are, this much Clojure programmers, in the industry, or basically it's about the same for Haskell programmers in the industry. But you can go work for Facebook. They use Haskell. Clojure too. In some of the companies in Bay Area. But the thing is, if you look at Golang, it's like 1,000 times more jobs than Haskell or Clojure combined. Okay, seriously. So that's, you want to consider that. But anyway, I'm not gonna talk about which language to learn, because I had talked about that before, and that's. So let me go back to the formal languages. So So yeah, so if you don't know formal languages, you can read Wikipedia, formal languages. But if this is your first time, you might find it confusing. It can be confusing to understand what they are saying. But let me just explain to like let me give you a informal explanation of formal languages. So you have a formal language is just a bunch of strings. Just think of it as a string, like like if a string in programming languages. That's so simple. So you just have a bunch of a sequence of letters. A B C. A sequence of letters. A formal language is just that you start with a string. Let's just say a string. You start with a string, then you have a bunch of rules. Each rule is basically find and replace. So think of in your editor, Emacs or Vim or whatever editor, you want to find function names and replace the function name by some other name. Find and replace. That's it. So you have several find and replace rules. For example, one of the rules says, replace all f by y, just for example. Then another rule says, replace all sequence of x, y, z by some other sequence of, a string. That's another rule. So basically, you have a bunch of find and replace rules, okay, and then you are given a starting string. Then at each time, anytime, you can pick one of the you can pick one of the rules to replace that, to change the starting string into some other string, and basically you repeat you repeat the process. So essentially, you have a starting string, you can end up with a bunch of other strings. And essentially, that's formal language. That's what it is. Okay, don't quote me on that. Okay, so go read Wikipedia. You can see, you can see what I mean. Go read, because I'm not, I'm not teaching formal languages. That's a topic I'm still learning. I mean, this is okay. So let me tell you why I find formal languages interesting. Because actually, when you actually study mathematics, for example, logic, mathematics is a huge branch of logic. Proof systems, um, homotopy type theory, proof systems, is so the whole thing. I mean, basically, we want to, we've been trying that for 50 years. We want to create a system. Wouldn't it be great if machines can automatically create new theorems and find new proofs, new theorems, like put out mathematicians, kick out all mathematicians. We don't need them anymore. The AI system just create all new theories for you. Einstein's relativity or whatever. The machine will find it. After all, it's just logic, right? I mean, if you are a programmer, you might think, if you never studied, proof systems, math logics, you might think, programmers, programming is all step by step, it's all machine, it's all so accurate and precise. Why can't they just, you know, automatically do things? We have lots of automations, right? Automation is so hard, we automate this and that. So we have been, people have been trying to find the automated proof systems. That's extremely hard, and in fact, that gave us lots of technologies and math, branches, math and theorems we have today. But the question about how to go about finding new theorems is very hard. But anyway, so all this has to do with foundation of mathematics. Like, for example, calculus. For example, 1 plus 2. How do you turn, we know what is 1 plus 2, we know what it means. So x squared equals to 3, how do you solve for x? We humans understand what it means, but the problem is that you have to turn this equation into formal logic, so-called, or in some form of logic, so that computers can do it for you. So, and that turns out that that is the problem. That's, it's hard. How do you turn a problem into a formal logic? So then you have formal logic systems. You have different logic systems with their presumptions and axioms and so on. But anyway, all these is kind of in 50 100 years ago, it became basically symbolic logic, which is what we are kind of familiar with. We want to turn English words into symbols. So you know so it became, in a sense, you can say, actually you can say, all math, it became, you know in a particular philosophy, okay, it became manipulation of symbols. So that's where formal logic, I mean formal language came from. So if you want to ask a question, how do you solve a problem, let's say, is it possible to solve a problem? You turn that into a formal language, like, just basically like strings, just or symbols, and you have a list of rules, and you want to ask, so if we have this system, is it possible by applying, this bunch of rules to arrive at a different string, which is a string we want? So we can ask if that is possible. You see, so now this problem has become so simple and very specific. You can start to write programs to do it. So that's the gist of, okay, let me say, that's the gist of my interest in formal languages, symbolic logic, the foundation of math, and proof systems. They are kind of all related. So 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 that's what I mean. Okay, so I've been talking like for 50 minutes already, so it's almost like we can call it a good chat. So small talk is father of Pharo, OOP, but not in Java, fucked up way. Yeah, so if you want to learn a programming language, not for a job, but just for the sake of learning, um, you have a lot of options. Actually, you have. I mean, just if you really just curious about, you know, you have a lot of options. You can, okay, Lisp is obviously one option. Um, of course, you can also learn Java, Ruby, PHP. I mean, that's kind of okay. That's different from Lisp. Then you can also, okay. Now Haskell is another option because it's very different. Again, it's different Haskell. Or you can go with OCaml, F sharp. They are all similar. So the the branches of functional languages, in the beginning you have Lisp, and somewhere, sometimes around there, you have a different functional programming different from Lisp. Basically, that's ML. ML stands for meta language, um, and the origin of ML is to create a proof system. We are back to proof system again. So ML is the father of. Then ML became Camel, standard ML, or Camel, and there's also Miranda. It's kind of, yeah. So anyway, so ML is a meta language. Then you have standard ML, SML, and that, I think, that also became, OCaml, and then F sharp is Microsoft's version of OCaml. And then you have, so Haskell is kind of there. Okay, it's, you could say they are the same family, but I mean, you could say, I mean, I mean, if you, of course, if you are a Haskell programmer, you probably know the history better than me. But so anyway, so so Haskell ML, and then what was I going to say about that? I forgot. So yeah, well, anyway, so yeah, the family of functional programming languages. But yeah, yeah, I wanted to say, oh yeah, there's something about um, small talk. Okay, so yeah, I never actually studied small talk, but because there's so many languages to learn, especially today, there are so many new ones too, and they are also useful. I mean, practical, and so I mean, so you don't have time to actually learn all the everything. And also there's a theory aspect. So for me, I want to get into proof systems. I mean, the math aspect, you know, um, and that's a lot, to study. So there's this interesting thing about Alan Kay. Okay, you might read this article if you are interested. So this is like my local version of my website. You can just wait, just so this is on Xah info. Just remove that, and there is my website. Alan Key on object-oriented programming. So basically, he says, today, what we know is OOP. He invented the term. He created the term. However, his concept of OOP is entirely different from, you know, what we came to understand, as OOP in Java or Python. So but anyway, in this article, he explains what he means, but I don't understand a thing what he is saying. I don't understand, you know, and he's talking about you know his idea of OOP is like you have cells, and each cells send messages to each other. Yeah, but what does that mean? Like programmers, they always talk about the fancy ideas, but what exactly do you mean cells? Like how do you, what's the syntax? How do you actually code it? But I suppose if I actually learn small talk, then maybe I understand. But anyway, his article, that is like makes zero sense to me. In fact, I think he's just a crackpot. He's just like he's a crackpot. He started some weird idea, and today's OOP is just other crackpots, created their own things. So um, old book. Old book. So you might be interested in computer modeling of mathematical reasoning. I don't know that book. Never heard of that book. Usually it's math modeling of computer programming, but this is reverse. The computer modeling of mathematical reasoning. That's kind of strange. I'll look it up. Um, so anyway, so yeah, so I think that's okay. So yeah, so I guess I talked about the stuff, like enough stuff for the day. So let me look up the book. The computer modeling of mathematical reasoning. Oh, 1983. Okay, one of the odd book, I guess, because there's no like reviews and stuff. I mean, no people, it's like nobody bought it. 1983. Yeah. Hmm. Interesting. So what else? That's the let's go back here. Great chat. Hey, thanks. So I guess yeah, that's it for today. Uh, you know, thanks for coming. Bye, guys.